Is your building sick? Or more accurately, are the people in your building getting sick? Hello, HVAC Control Pro. This is Eric Stromquist with ControlTrends.com and StromquistandCompany.com. Stromquist has been a master distributor for over 60 years, so we know a little bit about indoor air quality and controls and ventilation. So, indoor air quality is a key piece of what you have to do. So we've got a 3-part training series we're going to break down for you with Control Pro Tim Chamblee. So stay tuned for part 1. He's going to get into it and sort of introduce you to the principles of indoor air quality. And from there, he's going to take you to a deep dive.
Go ahead and get started with indoor air quality. See what it is. Let's define it. First of all, let's give consideration to a couple points. One is the expense and effort required to prevent most IAQ problems is much less than the expense and effort required to resolve the problems once you have them. And many of our problems with indoor air quality can be prevented just through education, people understanding the signs, seeing, and addressing. The worst thing you can do is if a problem is brewing, ignore it. I have had people tell me specifically, I used to have a little motorized camera. You could drive in ducks and full color HD, record it. I had a university tell me if I got near their place with that thing, they would have me thrown off. Of course, I would never do that without permission, but you know, it was, and he was because he also mentioned something about a shotgun. He was joking. But that's kind of the mentality. There's back when I was in the project management phase of my life, there was a local here to Atlanta hotel facility, an upscale facility. I would go in and on a monthly basis, just pay courtesy visits. You know, how you doing? You got anything you need? And they relied on me heavily for advice and of course for quoting work. Every time I visited, I would tell the chief engineer, you know, you've got a severe negative pressure problem, and we're going to be talking about what that means in this building. And you know, he'd brush it off. Every month when I'd go see Mike, you got a problem. And then I changed jobs, lost contact for a couple of years, and then had cause to go see him one day, and I noticed that when I went by there, they had scaffolding all around that exterior of the building, beautiful brown brick facade, taking that down. What had happened is because of this negative pressure problem he had, all this moisture from the outside was being sucked into the walls, and over the years it caused a severe mold growth problem. And they had to literally strip the exterior facade, strip everything on the outside wall, the sheetrock, everything, remediate, go back with a green board and back up with the brick facade. It was $1 million project that could have been avoided, and without spending a whole lot of money. That is the ramifications of indoor air quality and ignoring it. And it is a lot less money involved if you will address it up front and make sure that all your staff has the expertise to recognize the problems. Okay, so let's take a look at, I think, very interesting data. Before I put this slide up here, if I asked you, what do you think is the #1 indoor air quality problem? I wonder if you would say, well, it's probably mold. As far as problems in your average building. Now, I'm not talking about a building that's ate up with mold. I'm talking about your garden variety average building. Just head out in a direction, pick a site, look at 50 different sites, average them. This is what you'll find. Most of the IAQ concerns have to do with not enough ventilation. And ventilation is outside air. We've got to bring in the proper amount of outside air, and we've got to treat that air. Do it in a responsible, rational way. So, guess what? We deal with this, is that correct? Industrial hygienists deal with the microbial issue, testing and likes. So that's above our pay grade. But look at the small slice of pie that they deal with. Look at the large slice of the pie that we deal with.
We're probably unknown too.
Yeah, well, some of the outdoor contaminants, and we'll talk specifically about that. We have a lot to do with the major portion of this pie scale. But yet we don't consider ourselves indoor air quality experts, do we? That's sad. We need to be more focused on this issue. And let me tell you, it's not that difficult. You'll see. All right. So, manifestations. What's it look like if you have poor indoor air quality in a building that's populated? All right. Lowest level, you get some comfort complaints, just itchy eyes, watery eyes, or just tiredness. Now, the next level up from that is sick building syndrome, which that's where you have more manifestations of some kind of physical thing. I just don't feel good. And of course, that is usually brought on by watching a PBS documentary. And then you get to thinking, you know what? I think work is making me sick. Some of it is in your mind, but a lot of it is actually real. Now, sick building syndrome, you tend to be sick at work. When you leave, you feel better. You get out in the fresh air, so your symptoms start going away. Then we go to the next level, and it's BRI, building-related illness. That is where you are sensitive to something. By the way, have y'all ever heard apple a day keeps doctor away? Apples good, aren't they? Nothing wrong with apples. However, I have a slight allergy to apples. I eat apples. It makes me sneeze and stopped up and running out. They have an impact on me that they probably don't have on you. All right, so you see how different people can be sensitive to different things. Something that has no impact on you except good impact can have a bad impact. Just think about peanuts. Oh my goodness.
I'm allergic to chicken.
Yeah, that's not fair to be allergic to something like chicken. Nowadays people Google it. Red meat allergy. That is becoming more and more prominent, and that's a result of a certain tick bite. Google it. You might see some interesting information. What did we do without Google?
We didn't know.
Yeah. All right. Well, some people will, their systems, if they get just almost to a saturated level, they have a reaction that is far above and beyond the normal reaction with the general population. This is a very small slice of the building population, very tiny, but it happens. It's where something is a trigger, and then the least little exposure to the chemical or whatever can cause severe traumatic problems. And that would be the final one, MCS, multiple chemical sensitivity. Some doctors do not recognize this, some of them do. It's a little bit controversial. Some people claim that this is just psychosomatic, it's in their head. Other people say, no, it's real. I've known a person that had this, and to get around this person, you couldn't even wear cologne if you're a guy, perfume if you're a lady, hand lotions, things like that would bring a reaction on this person. And from what I could tell, just speaking to this person and getting their history, they were saturated. There was an event where they were saturated, they had a high level exposure to something that just did something to their body and made them ultra sensitive to chemicals. So most of the population don't fall there. They fall where, you just eyes are itching or burning or something like that. Okay, does that make sense? Any questions? Okay. Now here comes some confusion. What is acceptable IAQ? Well, it depends on where you look. If you look at ASHRAE, an older version of ASHRAE, they said air in which there are no known contaminants at harmful concentrations determined by cognizant authorities and with which a substantial majority, 80% or more, of people exposed do not express dissatisfaction. So what that's saying is, as long as 20% of the people aren't complaining, I guess it's okay. All right, now we've had to grow from this definition. So they amended this, ASHRAE did, in ASHRAE 62, says air in an occupied space towards which a substantial majority, and I'm not sure what substantial majority, what number that is. All right, of occupants express no dissatisfaction, which there are not likely to be a known contaminant at concentrations leading to exposures that pose a significant health risk. Boy, is that gray and fuzzy. You've heard of fuzzy math. That's fuzzy. EPA Building Air Quality Guide. And by the way, if you Google the EPA Building Air Quality Guide, they've got some good information. You can download a sizable manual that really goes into a very detailed explanation, look, and here's what you do, this is how you do it. This is how you structure your staff into supervision and all this. It's very comprehensive. I recommend it. Okay, what they say is it includes introduction and distribution of adequate ventilation air. And understand what ventilation air is. It's not air coming out of here. It's not your air going through the air ducts. It's specifically outside air. Okay, so it's saying we have to have adequate outside air. We have to have control of airborne contaminants, which means good filtration. We'll talk about that, and the proper acceptable temperature and humidity. So now they are really encompassing a lot more than some of the other definitions. And it says that a healthy indoor environment is one in which the surroundings contribute to productivity, comfort, and a sense of health and well-being. Doesn't that make you feel better? Still, it doesn't give us a whole lot of benchmarks, and this is what we need to attain. So what we need to do is have due diligence. Does that make sense? Okay. All right. So here's the fundamentals. We've got contaminant sources, we've got ventilation, humidity, and filtration. We're going to hit those main areas. So first, contaminant sources. You've got outdoor activities. What's going on outside? Do you have a huge building project? Do you have a stadium being built across the road? The occupants, what's going on with them? I have gone on IAQ walkthroughs where there was an individual that when I walked by, not just bowled me over. No, it wasn't that they smelled bad, they smelled too good. I mean, it's like somebody dipped them in this vat of perfume. Okay, that puts a lot of stuff it's distracting and sometimes irritating to other people. Office equipment, what's going on with that? Everything is manufactured, and in the manufacturing process, sometimes elements, chemicals are infused in this stuff. Formaldehyde is a very common one. They're working towards minimizing what they call VOCs, volatile organic carbons, and the list is huge. What that is, formaldehyde is just one of many. Carpets, that used to be a big contributor. You lay down a carpet and this stuff will off-gas for a month. Oh, actually it'll off-gas a lot longer than that. It's just after a month maybe the smell isn't quite so stifling. Copiers. How many of you have copy machines? Everybody. Does any of your buildings or any do you have large copy machines? Okay. In the that large copy machine makes ozone.
Makes what?
Ozone, which is great because I heard about this ozone hole. We need to. All right, so the refrigerant issue is gone. Now, I could speak for about 2 hours just about that, and so I can't go down that.
Their toner gets powerized too.
Yes, but the ozone, it irritates our lungs. And so that's a chemical that needs to be exhausted. So if you have a large copy machine, you really should have an exhaust above it. Okay. And like you said, the toner actually, very small particulates. And building materials, maintenance activities, construction, there's an awful lot of things that contribute to the contaminants around us. Also, we've got to look at building pressurization. I want to talk specifically about that a little bit later. That is huge. And it gets into an arena of, it's not just pressurization inside versus outside, it's inside versus inside. Pathways, we'll talk about that. Leaks and drafts, that gets into the air movement. We've got to have enough force coming out the diffusers to be able to mix the air. Now, we've got VAV systems in most of our commercial buildings that it varies the volume of air coming out. So if you've got your maximum flow, you've got great mixing of the air. If you throttle back to a minimum flow, sometimes the mixing is not quite adequate. All right. Of course, ventilation we're going to talk about at length. Why do we need ventilation? What does that do for us, the outside air? Well, whatever contaminant we have, and I mentioned one of the VOCs, formaldehyde. Well, we could have a formaldehyde, and then we could have a sensor for another thing, and then another thing. Like I said, there's hundreds of VOCs. Oh yes, I'll sell you one specific for each VOC. Just line them up on the wall. That's not practical. Now, there are available VOC sensors that will respond to a large variety of the VOCs, and we do have those available. They look like CO2 sensors, but what we typically do in your common commercial application, we just sense CO2. And why do we sense CO2? It's because that is an indicator of the presence of us. If there's more of us in there, we need to bring in more outside air. And then as we do, that dilutes and gets, that it takes care of some of the other VOCs that we're concerned about. Does that make sense? Okay. Again, another reference to building pressure, but demand air ventilation, we see that a lot, even in small applications. We see that a lot. Does anybody know what that even means? Demand ventilation, demand air ventilation. All right, you can put that on a 5-ton rooftop package unit. Has anybody ever installed a rooftop package unit and you put a economizer on it? Well, you're most of the way there for demand air ventilation. I'll talk about that just a little bit better in more detail a little bit later. All right, so if we use CO2 as the guideline, the litmus test on the quality of our air, what are we looking at? OSHA is saying 800 parts per million, ASHRAE is saying 1,000. If you get above 1,000, it starts to make you feel a little bit sluggish. Your productivity as an employee, if you are if you're around a desk, that's your job. The average person will perform better, be more productive if you have adequate fresh air coming into your space. Okay, and generally, you want it to be below 1,000. So what can we do? Well, we can get CO2 sensors.
So there you go. That's the end of part 1. Hope you liked it. Be sure to subscribe to the channel if you haven't already. Give us a like and reach out in comments. Let us know what you think. What's your biggest indoor air quality problem and how did you solve it? What are the tools you like to use to check indoor air quality? We'll be getting into that in episode 2 and episode 3. All right, again, I'm Eric Stromquist with stromquist.com. If you happen to need some controls, give us a shot. stromquist.com. We'll see you next time.